So we are starting section 1.6, that is graphs of transform sine and cosine. Let me remind you of what we have done. We spent a few lectures on graphing basic functions that would be like sine of x and also cosine of x, and also other functions. For the sine of x, you remember we justified the following appearance, that the graph of it starts at the origin, passes through markers at pi and 2 pi, so 0 pi, 2 pi, and the graph looks something like this, and then it keeps going. For cosine, we had a similar picture, except that at the start we are starting at the high 1. At pi over 2 we hit 0, so here's pi over 2, here's pi, 3 pi over 2, and then 2 pi. So the graph comes from this maximum, passes through this intercept, at pi becomes minus 1, 3 pi over 2 is 0 again, at 2 pi becomes 1 again. So that was sine, and that was the graph of cosine. Now, there's a topic that comes up in college algebra regarding transformations of functions, like shifting, scaling, all sorts of movements. The reason we insist that you take college algebra right before trigonometry, so that when we come in this section, things don't become too overwhelming. But I'll give a brief review of the ideas, and then there will be several applets you can play with. Hopefully we can make it through 1.6. Some of these ideas, again, are things that you actually did in college algebra. Let me just try to review some basics. So over there you learned about transformation of graphs of any function, not just sine and cosine. Now, given that much of your algebra revolves around this parabola y equal to x squared, let's go consider that. So we have this y equal to x squared. Now this, you can consider it like a physical object, and you can think about moving or reshaping that object, such as moving to the right, left, up, or down, doing other things, and you want to know what kind of modification to the formula will produce that kind of a movement. Like, suppose I want to move this thing to the right. Very good, very good. So if you want to go to the right, so very simple idea. I want to take something, just move it some other location. I can understand the concept of moving around. Question is, what is that going to do to the formula? What formula is going to have its graph being graph of a parabola, standard parabola, moved to the right by, say, 2 units. So this is something that you come across in college algebra, and if you followed it very well there, then you won't have that much of a trouble here. Otherwise, you're trying to learn algebra and trigonometry at the same time, it becomes overwhelming. So let's see. Those of you who remember this thing, you said to do what? Okay, so one suggestion is to write this thing as x squared plus 2. vicinity but not the correct answer. What do you think is the correct answer? Here's another suggestion. Y is equal to what? X squared minus 2. It's again in the vicinity but not the correct answer either. We are moving to the right by 2 units. You have to make sure that the tip of the parabola. Here's another suggestion. All of these things, we're going to study all of them, but that's not correct answer either. That's a complication. There are so many options, and which one of them applies. Like a dozen things to consider, and plus 1/2 here. So tell me, what is your suggestion? Okay, let me tell you what the answer is. In this case, is x minus 2 squared. You knew that, but it was at the tip of your tongue. You just forgot. Y is equal to x minus 2 squared. So one thing you learn in algebra, basic algebra, is that if you have a formula which has a picture, if you take that formula, replace x of it with x minus something, the net effect of it is that the picture moves to the right by the amount you subtracted from x. So if I written x minus 3, what would happen to this tip? So if I had said x minus 3 squared, that would be here. What if I wanted to go left? What do you think I should do? Suppose I want to go to left by 1. Rather counterintuitive. Students would look at it the first time because you say, okay, I'm adding, how come I'm going to the left? But graph the function, you will see. One of the easiest way to see is, suppose that I wanted to get you figure out this location of this tip. At what value of x would this thing assume its lowest value? At -1, this becomes 0. Is that right? At any value of x, you're going to be higher up. Is that right? Anything else squared brings you up. But when this parenthesis is 0, you're at your lowest point. So you have to set x plus 1 equal to 0 to figure out the low point. That sends you to x equal to -1 for the tip of the parabola. So the idea is in general. It has nothing to do with the parabola, has nothing to do with the sine and cosine. If you have graph of some function well studied, then if you consider graph of function, same function, but x has been replaced by x plus some quantity c, the graph of this will be obtained from the graph of the original by moving c units to the left. So move the original c units left, assuming like c is positive. If you have f of x minus c, you take the original, whatever you had original here, move the original c units to right. Okay, now what if I wanted to move it up or down? Suppose again I have my basic parabola here. Suppose this is what I start with, y equal to x squared, and I want to take this whole thing, like a piece of wire that is just being moved up 2 units. So every point of this is going to come up 2 units. What do you think is the formula for that? Y is equal to, all of our y values are going to be 2 more than what they were before. If you are shifting it up by 2 units, like imagine kind of perhaps a piece of wire just being lifted up 2 more units, whatever you had, you add 2 to it, that brings it up. But if you want to take it down, you want to take it down, say 1 unit, so every point of the original picture, wherever it was, it's being lowered by 1 unit. So what do you think is that one? X squared minus 1. So we say, if you say y is equal to f of x plus c, it means take the original and move it c units up. So we understand when we say move up means the original before you modified it, what are you supposed to do to it? In this case, if you add to the function, you go up. If you subtract a quantity, you are going to move down by c units. Now the language between here and here are actually kind of confusing, and you might not sense it right now, but on the exam it's going to catch up with you. Here we are saying adding moves the picture into the negative direction. Move left. Say you're adding, you're moving left to the negative direction. You subtract, you move right to the positive direction. Here the language is opposite. You add a quantity, you actually go in the direction you think you're supposed to go. You're moving up. You subtract, you move down. There is an explanation why that is so, and if you're interested, you can come and I'll talk about it to you. In short, if you want to have same kind of a language, you have to do the same thing. Here you are modifying your variable x to x plus c. Here, what you are modifying is the y value. So if you put the modifier next to your modified quantity, you will find that the language is the same as that. So let me write the same thing again. If I want to move the c to the other side, what would I write it as? Y minus or y plus c? Minus c is equal to f of x. So if I, instead of y of a function or an equation, I use y minus c, when I'm subtracting, I go up. Just same as this. If you're subtracting, you go right. Here you're subtracting, you go up. So if you remember to put the modifier next to the item that is being modified, the language is actually same in two cases. Why is it that you write it like this? Because from middle school you get used to having just y on the left and everybody else on the right. So the textbooks write it in this style and create a bunch of confusion as to what's really going on. There's a very simple, much more elegant way of writing it compared to what they do. Just that you have to pay a price of getting used to having more than just a y on the left hand side. So if you write this thing as y plus c is equal to f of x, the item that is being modified is clear. Y is being modified, you're adding a c to it. What's the effect on the picture? When you add, you're going down. Okay, all of these ideas can be applied to sine and cosine as they can be applied to any parabolas or any general shape. It gets rather crowded when we want to consider everything. So let me just show you some pictures so that we have an idea what we are talking about, and hopefully you can go on web and play with some of these things and get your ideas confirmed perhaps before you pick an answer or something like that. So there are plenty of these type of applets on the web. You can choose any of them. I'll maybe put one link for you and you can search yourself and find any of these things you want. So the idea here is that here's the parent function, y is equal to sine of x. There are all sorts of things we can do to it. Here's the original x. Okay, I can subtract something from it. I can add something to the function. I can multiply my x. I can multiply my function values and such. What's the effect of any of these things? The ones that I explained right now was the last one I explained was what if I add a quantity to a function? Let me just remind you what we are talking about. If I had y equal to x squared, the original. This is my original. What if after I'm done with the function, what if I'm adding something to it? Or what if I'm subtracting something from it? Adding a quantity after the function is all done. Okay, I've squared, I'm all done with that. I'm adding a quantity or I'm subtracting a quantity. What does it do to a picture? Let's see. We are adding or subtracting. This is a k at the very end. What do you think is going to do? Here's my k, my slider. What do you think is going to happen if I go to 1? Wow. Okay. You can think about it as taking the midline of a picture, moving it up. So adding a quantity, we are going to understand it as moving the whole picture. The whole picture, it's better to have some handle on the picture so that you have something to work with. Where are our handles? Handles are like this point, 0, pi, 2 pi. These are the crossing points. Together they form the midline of our picture. So that midline moves up as much as you added the k. Like here is 0.55, the midline went up here. You can also track maximum minimums. You can say maximum from 1 now has to be at 1.55. Minimum used to be -1. You're bringing it up by 0.55, so it's going to be has to be at 0.45 and such. So that's the effect of taking your picture, moving left or right. Okay, I bring it back to the original. Now, we are as yet not touching A and B so that things don't get too crowded with too many changes all at the same time. Next change is in adding or subtracting some multiple of pi, or just adding and subtracting. Let me remind you, what was it that we just did? You had a question? Okay, so here we had our basic parabola. What's that? No, they're just using a letter. And by the way, when you are looking at these pictures on the our website, those thin, these type of pictures don't get recorded very well because the lines are very thin and the resolution is not high enough, so you might not be able to see any of these things on the web when this is being recorded, but you can always go to the actual website and repeat everything for yourself. So here was the other style of modifications. Here was our original. We said, what if I want to move it to the right or left? If I subtract, I go to the right. If I add to the x before I square, I go to the left. Let's go practice it here. Who is responsible for that is this quantity. Now for ease of graphing it, whoever made this thing has this thing multiplied by pi, so perhaps you are adding or subtracting some multiple of pi. That is recorded in h. So what do you think is going to happen as I move this h to positive territory? Like, what if I take this thing and move it up? Should play with this thing and then first guess what's going to happen and then move the slider and see if your guess is correct. Suppose h goes up to 1. What is going to happen to this picture as I move it up? Very good. Move to the left. Well, we forgot one thing. This website is recording this h as the amount that is being subtracted. So the way this is set up from the get-go, when I move the h up here, it is taking that quantity and subtracting it. So I'm at h equal to, let's go to 1. It's automatically subtracting. So when I go to positive territory, it's going to the right. Right, let's go back again, start from the origin. Reset. Okay, so h equal to 1, it means in this picture he's going to subtract 1 from x. Actually subtracting pi from x. So as I move this thing to the up, the picture is supposed to move to the right by that amount in radians. So by the time I come here, I have moved up by, this was the original, that it has moved up here, and so on. Okay, now let's go back to picture that we had at the beginning. Again, we go back to college algebra because you have most practice with these things, y equal to x squared. So I take y equal to x squared, which is a parabola like this. Now, I might decide to make this thing a lot thinner, or if you wish, a lot taller. I want to do something like this. The tip staying in the same place. I'm not moving the parabola, I'm just making it thinner. Like sometimes you see on these diet programs on television, they take a picture of a person and just stretch it this way and that way to make it show before and after. Something like that. We are just stretching this picture. We are not taking it and moving it up, so don't confuse it with this. Suppose I take every height that I had and double it, or triple it, or something like that. So whatever this one is, perhaps I am tripling it to come up here. Whatever this is, I am tripling it to come up here. Whatever this one is, if I was at the origin, I stay where I was. So what do you think is the formula for the blue picture? So every height of this is 3 times the height of the original one. Okay, 2 or 3 or whatever number you want to stretch it by. So if you have a stretching factor, sometimes it's called the scaling factor. Just like on the maps, they say scale it by such and such number. Scale 1 inch is 1 mile or whatever it is, same kind of idea. If you want to scale it, stretch it by a certain number, you multiply it. What if I wanted to make this thing a lot wider and shorter? Suppose I wanted to take this parabola, make it like those satellite dishes that you have that are kind of wide parabolas. Suppose this, I take the original height and cut it so that this is a quarter of what it was before. So the height of the green parabola at any point is a quarter of what it was over here. Like if original height was like this, I divide it by 2 and then divide it by 2 again, and that's supposedly my new height. So how should I make a formula for the green one? Multiply by fraction. So you can say stretch by a factor of 3, you can say shrink by a factor of 4, all sort of languages you can use. The neutral language is a scale. Scale by a factor of 3, and this one you say scale by a factor of a quarter. If you don't want to think about if you are making it taller or shorter, you're just thinking about changing it, you use the word scale. I'm scaling by a factor of 3, so in this case it looks like it's getting taller. Scale by a factor of a quarter, it means I'm shrinking it. To understand this thing physically, what you want to think about is that your original picture is printed on a rubber sheet. So imagine this whole thing is a rubber sheet. That rubber sheet is nailed down on the x-axis. That's the only place where it is nailed down. So we put a bunch of nails here and nail the rubber sheet to x-axis. Now the upper side of this thing is supposed to be a movable part. I can take this thing and lift it. Excuse me, I can take this thing and stretch the whole rubber sheet. So that rubber sheet is going to become perhaps this long. And now, since down here I was tied down to x-axis, that point stays put. But everything else got stretched upward by whatever factor you are using. Okay, how does that show itself in the graph of sine and cosine? The factor that is in front that plays that scaling factor, A, right now it is set at 1, meaning the coefficient of sine of x is 1. If I take it, make it to be 2, what do you think is going to happen to my picture? Describe some of the critical points of this picture and tell me where they are going to go. Like one of the critical points is this high point. Where is that going to go? As I move to 2, here, it just gets stretched. Notice that midline is glued to the x-axis. That is not moving. It's just everything else is being scaled by whatever scale factor you had. So whatever the original was, it is, here you can see. Kind of. You play with it when you're so you see, well, not letting me. On the original, the height is 0.98. On the scaled one, it is about double of whatever we had at the beginning. Good idea. Go to the other way. Now we go A towards 0. We are shrinking it. At 0, you just killing the whole thing. There's nothing left. You go to the other side. It just flips the sine curve. You can flip in the other direction. So negative scale factor. A negative scale factor has two effects. One, negative reflects it, and whatever scale factor you have, that is still applicable. So if you have -2, this is going to flip over and become twice as tall. Last one of these things is the effect of this factor B. The factor B is going to shrink or stretch. What's that? You're trying to guess? Okay. Very good. When we go to 2, yes. Very good guess. Factor of B has to do with the so-called frequency, which means how many ups and downs you have per, say, unit of time or something. The higher the B is going to be, the faster the function is going to go through its ups and downs. You're helping the function by boosting the factor of x. The higher this number is, the more ups and downs you are going to have per unit interval. So that's what's going to. If you go below 1, what do you think is going to happen? Like if you go up to half, see, 0.5x, that's making the function lazy. It's not moving that much. It's taking twice as long as before to do the same thing it was doing. This function was going up and down on pi, on an interval of pi. Now it's going through up and down the first half cycle on an interval from 0 to 2 pi. So these are the 4 modifiers of a sine or a cosine curve we want to study. And now let's see how we are going to do it. So let's take sine of x and do everything to sine. Exact same sort of ideas apply to cosine. So here's our original. Let's see if you remember. Suppose I write y is equal to sine of x plus 2. And to avoid confusion as to what is 2 doing, I might sometimes write it like this so that you don't misread this thing. X is being fed to the sine. After that's all finished, after this is all finished, then you are adding 2 to it, as opposed to adding 2 to x first. So what is that going to do? Excellent. It's good. Well, that That is the danger of this section. So eventually the question is, what is it going to do, up or down? You can always try it out on several important points. That's actually one of the fallback positions we are going to introduce. If in doubt, track these 5 important points. See where they go. That's kind of a safe way of answering. For example, suppose we are doing this thing in radians. So our maximum happens at pi over 2, or 90 degrees. Just take 90 degrees and plug it in this function. What are you going to get now? Sine of 90 plus 2, what's that going to be? Well, what's the sine of 90? 1. And 2 makes 3. So does that give you a little bit of idea of what's happening? So at least I know this point is at height of 3. Now how about these crossing points? This is at 0. Suppose I feed 0 to this function. What happens? Sine of 0 is still 0. Plus 2, I have come up 2 units. Is that right? 1, 2. These have to be same height. These were zeros. You add 2 to it. You are at, so you get an idea that your midline has moved up here. Well, let's try some more points. Suppose I look at this one, 360 or 2 pi. Well, that one we already know. Well, let's see. At 270 or 3 pi over 2. Original sign was at -1. Now this is -1 plus 2 makes a total of what? 1. So if you track these 5 principal points, you will have an idea of what is happening. If you get confused on all those rules of going up or down or compressing left or right or whatever, you have this alternate way of answering it, which is going to help you. But the expectation, if you're continuing from this to calculus or something in science course, the expectation is that you understand this thing quickly in a matter of a second, as opposed to plotting point by point. Right now it's okay to spend like 10 minutes to convince yourself, but I'm actually going up. Okay, but once you become an engineer, it shouldn't take 10 minutes to do that. It should be just a matter of a second to realize, oh, actually I'm going up. Okay, so this one you understood, up by 2. To make it clearer, it's shift up by 2. What if I had sine of x minus 3? So how do you describe it in plain English? What should I say? Instead of shift up by 2, what happens in this case? Move down. So we say move down or shift down. So if you had your original picture looking like this, this one, so you take this points, okay, -1, -2, -3. This is my new midline. Everything revolves around that. So you can just go up and down, wind around this midline, new midline, you are all set. So, okay, next, suppose I ask you graph y is equal to sine of x minus, now when you are in college algebra, your favorite numbers are just 0, 1, 2, 3 and such. When you come to this course, our angles, our favorite numbers are either 0, 30, 45, 60, 90, those type of numbers, or pi third, pi sixth, pi fourth, and that kind of number. So let's try both ways. Suppose I say x minus 30. Understanding is that you're dealing with degrees. Okay, if you're dealing with degrees, let's draw the whole picture in degrees. In degrees, we go through 0, 180, and 360 to make a complete cycle. Now, what did we say? What happens to a function? If you subtract from x before you feed it to your function, doesn't matter what function it is. If you say x minus a quantity, what kind of a movement does it create on the picture? So this is why this is the grandfather, or just the original sine of x. We are going to go where? Right. Now we have to be correct on this correct scale. Like if this is 0, this is 180, this is 90, and 30 is going to be a third of this. So the picture is going to move by, here is going to be, let me draw it in black maybe. Start, instead of 0, is going to start at 30. The maximum, instead of being 90, is going to move to 120. The next crossover, instead of being 180, is going to be at what? Everything is moving to the right by 30, so that's going to be 210. Is that right? The minimum used to be at 270. Where is the new minimum? Where is it? 300. And the ending, instead of being 360, is going to be at 390. So you start from here, you go up, you come down at hit the bottom at 300, come back at 390. Picture isn't that good, but so this is graph of y is equal to sine of x minus 30. Let's do it again. This time, practice with radians. Sometimes they tell you draw something like this: sine of x minus pi over 4. Implicit in all of this is that we are doing everything in radians. So from the context, you have to tell, is somebody all of a sudden interested in this peculiar angle of pi 4 degrees, or is he talking about radians? There's always a room for confusion there. Just make sure you're aware of what's going on. It'll be okay. So again, we have our original sine. This time I mark it in pi. So when I say pi over 4, I want to get a reasonable picture. Where should I start my picture at? Give me something about, okay, this is pi over 2. Pi over 4 is going to be a quarter of this half cycle. What is that? Yeah, it's x minus. Just try to guess what it should be. Okay, so everything's going to move to the right by pi over 4. Remember, this is pi over 2, so this is pi over 4. This is going to be 3 pi over 4. So we start at this point, we reach the maximum at this point. We were hitting the ground at pi, we are going pi over 4 after that. Pi plus pi over 4 is 5 pi over 4. That is where we are descending. We were hitting the minimum at 3 pi over 2. We are adding pi over 4 to that, and that makes it 7 pi over 4. That's our minimum, new minimum. This was 2 pi. You add pi over 4 to it. That makes it 9 pi over 4. So just imagine the red curve being a wire. You are taking it and moving the whole thing to the right by pi over 4. Moving to the right means the following. Like taking each of these points, here the maximum to maximum, this intersection to this intersection, this one to this point, this minimum to this this intersection back to that point. Everybody move to the right by pi over 4. This. Okay, next type of movements. Suppose I have y is equal to say 2 sine of x. We want to graph that. What is that going to do? Again, we draw the basic. That one we should be quick on. This is, suppose this is my sine of x. 0, pi, or 180, maximum 1, minimum minus 1. The factor of 2, what is that going to do to the picture? This is going to, say it again, stretch. Which direction? You have to specify stretching. Are we talking up or down movement, or are we talking lateral right or left movement? Up and down. So this is going to stretch it vertically by a factor of 2. Stretching vertically means if you were at 0, you're still at 0. If you were at 1, no, you're at 2. If you're 0, you're still 0. If you were at minus 1, you're at minus 2. Remember that analogy we had with a rubber sheet? X-axis is stuck, everything else could be stretched. Up here, down here, we are taking it from both ends and just stretching it in that fashion. So this becomes y is equal to 2 sine of x. Let's do one more of these things before. So how about y is equal to sine of 2x. So y is equal to sine of 2x. This is the, excuse me, sine of x. That is our original function. Now, if I make x to run twice as fast by aiding it, by doubling it, when am I going to reach my maximum? On the original, when x was pi over 2, I was reaching my maximum of 1. What should x be so that 2x becomes pi over 2 so that the whole thing reaches its maximum? What should the value of x be so that when you double it, you match the offer from the other one? Let's set it up. We say, I want the input of this function to be pi over 2. Why am I interested in that? Because I want to see where am I going to reach maximum on this function. These are main points. We said these 5 points are the main points. If you track them, you got it made. So let's track this one. What is the importance of this point? This is a maximum point. Here, how did it happen? When the input of the function became pi over 2. Now we ask ourselves, when is the input of the other function become pi over 2? So we say 2x has to be pi over 2. What does that mean? X is pi over 4. So I divided by 2. And that means at pi over 4, I reach my maximum here. Let's also go ahead and find out what happens to this point. When did we get to this point? When the input of this function was pi. I ask now, when is it that 2x matches that pi? So when x is pi over 2. When x is pi over 2, you double it. You get pi, and sine of pi is going to be 0. So this point is going to move to here. So far we know this first hump of this picture has been transformed into this. That point came here, this point came here. Let's go figure out what happens to this point. Well, where does that one happen? That happens when the input is 3 pi over 2, we get to our lowest point. Lowest point is 3 pi over 2. I ask, when does this become 3 pi over 2? So 2x is equal to 3 pi over 2. X becomes 3 pi over 4. So this is 3 pi over 2. Half of it is 3 pi over 4. That is where I'm going to reach my minimum. Finally, this is 2 pi. When this becomes 2 pi, the function is gone through its whole cycle. We ask, when is it that this one reaches 2 pi? So I say 2x is equal to 2 pi. That means x is equal to pi. So this point has come to here. All in all, it means what has happened is that this picture shrunk by a factor of 2 in the horizontal direction. So the effect of this 2 here is that you shrink horizontally by a factor of 2. Now we talked about all of these individual movements. The book pushes you to consider all of them mixed up all at the same time. That becomes a bit more challenging. We try a couple of these things next time, and then we are going to move on to the next topic. So reading 1.6 is going to take a bit of time from you. Make sure also consult the website to have applets to work with.